I'm Andrew McNamara. I work at Red Hat. I started off at Red Hat being a developer, getting software through the build system. Had so much fun helping other teams get software through the build system that I moved over to actually work on the build system itself. Now I'm also a maintainer of SLSA with a couple of the other folks around. And today I wanted to talk to you all about how we can let devs be devs without sacrificing the security. So to start off, let's think a little bit about what it means to be a developer. For me, it means that they can build off of open source software. They can reuse a lot of the libraries and packages that are out there. They don't have to rebuild everything from scratch. But that often comes with exploring new problems, exploring new spaces, seeing the solutions that other people have in order to take advantage of them and leverage them themselves, while also using tooling that's supportive and not disruptive. This isn't always the reality that developers face, especially if they're building in a system that maybe it's an enterprise system where the security and the supply chain security is a high priority. So since I'm wearing blue socks today, let's look at what a developer experience might be for a company called Blue Socks. So they want to easily build artifacts. You might be familiar with GitHub Actions, where you can clone the repo, you can fork the repo, you have all the build steps right there. You might have to make a couple configuration changes, but by and large, you know how to build artifacts and it's relatively easy. At Blue Socks, there's a lot of checklists, there's a lot of people that you have to talk to, there's a lot of process you have to go through. Sometimes it feels like it's just for the sake of process. And it's not an easy process. It's not easy to just start building artifacts. So you have your artifacts building, great. What do? Well, if you're a developer, you have, again, your build process right there. You can modify your jobs, you can add debug information, logging information, and you can figure out what's going wrong and what's not meeting expectations. But at Blue Socks, it's not that easy. You might send your job out to a pipeline somewhere, and if you're lucky, then it's going to be instrumented so you can actually see what's happening, you can understand what's happening. If you're not lucky, well, maybe you have to create tickets, ask other people can you add more information so I can figure out what's not working right? You have to wait some time. Or if you're really not lucky, people aren't able to get to your tickets, you might feel like you have to be an artist, recreating the system in some environment so that you can instrument yourself and understand why your build isn't happening like you want it. You want to explore new technology? We can't do that at Blue Socks. It's not like using an open source project where, again, it's just like building new artifacts. You have your repo, you're building off of some other package, and it has all the build steps there. You know how to build it, you can tinker with it to change it how you want it. So what do at Blue Socks? You create tickets, you wait some time, wait for more functionality to be added to the build system, more pipelines to be created, and then the build system has a problem. They keep adding more pipelines, more processes for getting these artifacts built and shipped. So they have to maintain those, they have to audit those, they have to monitor them, and eventually they're going to have to figure out how to decommission some of them so they don't have lots of gaping security holes. So I'm not trying to say that security isn't important, but we can have secure software supply chains without impacting developers like this. So let's look at SLSA for a little bit and see how it might be able to help us. Considering just the build track, there's two main concepts. The first one is hardening the build system so that the builds are isolated. You're not going to have one build that's going to be able to taint or compromise another build. And then the other one is you're going to generate provenance. The provenance that's generated, it needs to be accurate. You have to have it generated outside of the build process so that it's actually an accurate picture of what happened. And it has to have that cryptographic attestation. So taking SLSA and looking at a specific application of them in Tekton Chains, and the other image here is for pipelines as code. We can focus on hardening the build platform. Tekton is our build platform. We can lock down the service accounts that are used to run the pipelines so that you don't have the tasks in one pipeline that are affecting the other. You can then focus on generating the provenance by enabling chains, which observes what happens in the pipeline runs, and then it generates that attestation and attaches it to the artifact that was built in the pipeline. And then you can also use pipelines as code to make it simpler to onboard, because you can create samples or you can create templates of these pipeline runs to say, hey, you want to build a container image? Well, here's a pipeline. You can clone, you can fetch all your dependencies, you can build it, you can run all these tests. But that doesn't enable flexibility, because you have the provenance, but what are you going to do with it? So you have to have flexibility while still managing risk. Tekton Chains, it generates a detailed provenance, and that it gives you the picture of all the different tasks that are used. It provides you all the parameters that are input. It provides you with all the results from those tasks. And so if you trust the task, you can trust the results. And then based on the results, you can say, or based on the task and based on the results, you can say, does this meet a threshold of risk? Are the tasks that are used appropriate for the application? And it's really, it allows you to create policies for a sliding scale of risk. If you don't want to, or if you want to build artifacts, but it doesn't meet the bar, the quality bar for releasing to production, it can still be released to stage or to a developer environment. And so as I've been asked many times what the value of provenance is. People see SLSA and SLSA provenance as something onerous to implement, but they don't see the value. What I'm here to show you is that if you generate provenance, if you generate detailed provenance, it allows you to give the developers on the platform flexibility while still allowing you to manage the risk and protect the end user, because you have those bars that have to be met for the software. So let's go through those first three examples again. Developers can build artifacts in this system. As I said before, we have pipelines as code that actually submits a pull request to your Git repo that has the pipeline run. This has all your build steps. You can have a different pipeline run for your pull requests and for your push requests, or for your push builds. It's your pipeline. You can customize it. And if you want to add unit tests, that's great. As long as those unit tests don't affect the resulting artifacts, they'll still pass enterprise contract policy. And since from the start you're generating that provenance, if your build and if your customizations don't meet the policy, you can see the warnings. And so it enables a policy-driven development where there's not an opaque checklist, or there's not additional checklist items that are hidden underneath the crease. You can see all the items from the beginning, and you can work iteratively to resolve these policy violations in order to release the artifacts, release the software to whatever that target environment is, whether it's an internal deployment or some environment or artifacts you're providing to customers. So the developers want to troubleshoot builds. We're dealing with Tekton here. You have a pipeline run. Inside that, we have task references. You can either you can use the bundle resolver or the Git resolver. This just points to the task definition. Within this OCI artifact, we can see the spec for that task. Just take the task as it's resolved, swap out the resolver for the actual task, instrument it, modify it to however you want to get your task to work. Wait. That's not the task that I wanted. That's not the task that I want you to release. But enterprise contract will be able to see that you're not using a trusted task. It's not going to let you release it to production, but that's okay. You can still release it to dev. You can still release it to stage if it's okay with the ProdSec representatives. So it allows you to have that flexibility to troubleshoot and to explore without compromising the risk and the risk-based assessments for that target any of the target locations. So you want to explore new technology? The task is yours. Again, you can add in a new task reference. You can, so in this little snippet, after we clone the repository, we're just building, maybe we're building an AI model, and we're doing that in our pipeline. Great, we're producing an artifact. We get the provenance. But nobody's looked at this task. It's not trusted. So again, it allows the developers to explore. It allows them to create these artifacts to see if it's going to work within the portfolio, but it's not going to meet the requirements for release. So we have all these different pieces. It can be a lot to manage them all. One of the things that Red Hat has done, we've combined, or we have Tekton Chains, pipelines as code, and enterprise contract that we've merged together into Conflux. So you can go confluxci.dev. We have a Git repo, confluxci, or Git org, confluxci as well. And you can deploy it. You can play around with it. And we're using Conflux to build our own binaries, to build our own container images. And we're gating our releases with policies, and we're making those risk-based judgments ourselves. That was way faster than I practiced it, but that's okay. We have 9 minutes for questions. Yeah, Tom.
How easy is it to get Conflux set up for
What do you mean by getting Conflux set up?
Let's say that I'm a small company and I'm looking for a new CI system. How do I start using it?
So it does take some configuration. I know that if you go to Conflux, so this QR code on the left, if your phones will get it, it's for Conflux. The one on the right is for enterprise contract, to the websites, and then you can go to the Git repos after that. It takes some configuration. There are an install process that I know works on kind. So you can deploy it, you can configure it, and you can start running Tekton. We are working on having that also deployed to EKS. And so it's a more robust deployment. It takes a little bit extra configuration to enable pipelines as code, just because you have to configure the secrets so that pipelines as code can push to your Git repo. Yeah, Tom.
I suppose if, like, for an existing project that might already be using some other CI system, how much work is it for them to, like, port their actions, their builds to
Yeah. So we have, within the org, within the Conflux CI org, we have a lot of tasks that we use ourselves to build different types of artifacts, to run different kinds of tests. And we also have pipelines that we use to base our own builds off of. So if the use cases are the same as what we have there, then you can reuse those same pipelines. We are actually working on standing up a Conflux CI instance for the Fedora project to use. So we're using this internally, and we're trying to get it working so that Fedora can build not just the container images, we want to also build the RPMs on there as well. Any other questions? Yeah, Zorn.
Can you go a bit into how adding a custom task to the pipeline doesn't compromise the whole delivery process?
Right. So I should say, one thing that I forgot to mention when you're exploring new technology, you get your task to the point where it works and you want it to start being able to pass. You want to be able to start releasing these artifacts. There is a process to get them to become trusted tasks. So you're not just stuck at the exploration phase. You can pivot from exploration to actually being able to release these artifacts. And that might follow some sort of checklist that is special to Blue Socks, but that is going to be a required process regardless. The great thing is that for future artifacts that are onboarded to use this pipeline, you don't have to go through that same process. So your question was, how do we verify that custom tasks don't actually compromise the security. So this gets into the isolation a little bit. We already have isolation of the pipelines. That one pipeline can't affect another. And one of the things that we've actually done is that there is a TEP for Tekton for trusted artifacts to enable you to verify the integrity of content when it's used. And we have an implementation of that uses OCI artifacts. So instead of using a PVC to transmit data between tasks, anything can modify the PVC. I think there was reference earlier to somebody was saying, who knew that my unit test, my integration test was modifying the content on PVC? We don't have to worry about that because we have a git clone task. At the end of that git clone task, we push the content to the OCI registry. We record the digest of that in a Tekton result. If there's any other tasks in the chain which are touching the data, which will actually end up building or be consumed by the build task to produce the artifact, then the same thing can happen. And then when it comes to the policy verification, the enterprise contract, they'll see the entire provenance. It'll be able to map the steps that were involved in the build process, and it can track the provenance of the data, making sure that the digest of that OCR artifact is the same as a digest that between production and consumption. So we have the ability to guarantee that the data that was generated by the trusted task is the same one that's consumed by the next trusted task. Anything else?
Which level of SLSA do you
Well, I think the level that I've seen documented by many people, since SLSA build only goes up to level 3, is level 3+, because the build task that we have also can produce a hermetic build. We can restrict the network from the builds. So we can produce what used to be the level 4 in the 0.1 spec, but we can achieve level 3 as it is in the 1.0 and the still soon to be 1.1 spec. Awesome. Thanks, everybody. I'll be around if you want to talk more.